In this video, we're going to show you how our group went from a breadboard circuit to an operational and deployable payload. The operational environment is ever-changing. The warfighter is often required to operate in denied and degraded environments. In these theaters, the operators require a rapidly deployable and responsive solution to fill communication gaps. HABCraft demonstrates the viability of using commercial, available, low-cost, easily deployable, and replaceable payloads to communicate with a ground source. The primary objective of our project was to design, test, and deploy a low-cost, high-altitude balloon payload that was capable of transmitting the status using an LED. The secondary objective was to use a sensor to collect atmospheric data off the payload. Mission requirements were provided. They included limits for weight, mass, and how data was transmitted from the payload. Our team determined that using a tether to moor the balloon for testing was the best course of action to meet mission requirements. Let's take a closer look. Starting with the breadboard circuit, we began with soldering components for testing. The first design criteria was finding a battery that was small enough.
In order to facilitate case sizing and follow-on electrical layouts, AutoCAD was used in the design prototyping phase. A model of the proposed design and components was created using AutoCAD. Once case sizing estimates had been completed, Tinkercad, which is a cloud-based computer design platform, was used to create case models based on the component layout. Multiple prototypes were created and tested, and you could see it in this layout and showcase as we have here.
After the design review, we modified the circuit layout to incorporate 3 LEDs.
The final case design was sliced using Kira and printed on an Ender 3 using PETG. We used a Python code with both try and while true loops. Using the try command, we could detect and signal any exceptions that occurred. Our code records data every 10 seconds and then flashes the LEDs once, unless an exception occurs. The exception, or error, will cause the LEDs to flash every second, signaling a fault in data recording.
The team conducted a bench test where it confirmed the weight, dimensions, and the functionality of the payload. During a static test, the team confirmed the ground station protocol and was able to detect the payload over a mile away. Further environmental testing was also conducted. During the static test, an anomaly was detected in which the code was not writing a new file.
I actually wanted to write the code wrong so that it would not work to make sure that it actually was seeing.
After some minor setbacks, we finally were able to fly our payload on a high-altitude balloon. Using Raspberry and iOS on an old laptop, we were able to confirm that the code recorded on site. From a conceptual circuit to a design to a developed payload, Group 4 was able to meet 7 out of 8 mission objectives.
Like hot dog or hamburger? Hot dog. So I usually do it in the zip line. So I did it hamburger and then pork. You're saying so it should be you should have done a hot dog, hamburger, hot dog. Which I did. Oh.